This is the second um, video for the 6.3 exponential functions solving equations. The last one was when we were graphing them. And what we're going to be doing is learning how to solve an exponential equation. And this one's actually the easier of the two versions because later on in the section we're going to find out that the bases cannot be made to be the same. But in this section 6.3 they can. So what we're going to do is write an equivalent expressions to make the bases equal if necessary and if possible. Now in this section they will be possible. Later on that won't be possible and we'll need a new technique to solve those types of equations. But in this section it will be possible. And I say if necessary because sometimes the bases as the problem is written out, it's already the same. So sometimes it's not necessary to do any work at all. Second step is to, since the exponential functions are one-to-one, we can drop off the bases and set the exponents equal to each other. And set the exponents equal to each other. And then the third step is just to go ahead and solve the equation. So you're going to find that this section right here, this part of the problems, are very, very easy to do. So what we got going on here is a 5 to the x minus 2 and 5 to the 3x plus 4. These are two different exponential functions. You can actually graph each one of these functions. And what you're doing is you're wanting to know when this exponential function equals this exponential function. They're going to kind of look the same. Both of these actually looks like a backwards L. And at some point on the Cartesian plane, they're going to cross. And that's our goal, to figure out what that point is to figure out where that crossing is going to happen at. So that's what these little step procedures are going to do for us. So this is an exponential function. So is this, finding out where they cross on the Cartesian plane. So this is what it does. So we're going to write an equivalent expression. If the bases, to make the bases equal, they already are. So this won't be necessary to do anything here. All we have to do is drop off the bases and set x minus 2 equal to 3x plus 4. And so we'll move the x over here and make that 2x. And we'll subtract the 4 over this side. That's a minus 6 divided by 2, divided by 2. X equals negative 3. So at x equals negative 3, these two exponential functions will actually cross. And the actual value that happens is, well, to figure that out, you'd have to put negative 3 back in. So I think it's a very small number because it's going to be 5 to the negative 5, which is almost on the x-axis, just barely above the x-axis. So, but at x equals 3 is what we're looking for. So as you can tell, this is not going to be hard at all. So the example 2, e to the x squared equals e to the 7x plus 8. So this one's not necessary to do work because they already base e on both of them. So we just set x squared equal to 7x plus 8. Now sure, this one's more difficult than the first example because it's quadratic. But we have our techniques on how to solve quadratic equations by factoring the quadratic formula. So, but that's old school there. That's just old stuff. I mean, so it's just one little extra step here. So it's going to be x minus 8, x plus 1 equals 0. So x equals 8, and x equals negative 1. So not too bad. So actually, these actually cross twice, two places. And then on this one, now this was the first problem that we're going to have to actually do some work. And that what the main way by that is make the bases the same because this base is 2 and this base is 8. They're not the same number, so I can't just drop off the bases right now. And the next, like I said a while ago, sometimes it's going to be possible. It's not even going to be possible to do this, so we're going to have to learn a new technique a little bit later. But right now, the 8 and the 2 can be converted to the same base, namely the 2. So this is 2 to the x plus 1, and 8 is 2 cubed. Now tack on the 3x minus 2. So then you can just drop off the bases. You got x plus 1 equal to 3 times 3x minus 2. So this becomes x plus 1 equals 9x minus 6 when you distribute the 3. So move the x over here, and that's 8x. So add 6 over here, and that's 7. Divide by 8. So it looks like about x is about 7/8. So just shy of 1, 7/8. These two graphs are going to actually hit each other. So x equals 7/8. But if you notice, I had to change the 8 to 2 cubed, then drop off the bases. So if you look at example 4 here, 8 and 16, now I cannot change 16 to have a base 8 like I could change the 8 to make it base 2. So as a matter of fact, on this one, I'm going to have to reduce both bases down to a smaller base. The 8 is going to go down to base 2, and so is the 16. So 8 is 2 cubed again, and then tack on the x plus 1. So what do you think the 16 is going to be? If you said 2 to the 4th, yeah, it was 4 squared. That's true, but 4 is not base 2. So I need to change 16 to 2 to the 4th, so these two numbers will match. And then tack on the 2x plus 3. Then I can drop off the bases. So it'd be 3 times x plus 1 equal to 4 times 2x plus 3. And for time purposes, I'm going to let you guys figure that out on your own. So, but I will tell you, I have to distribute the 3 on the left side and distribute the 4 on the right side, rearrange the terms, and you're pretty much there. Now, 5 to the x plus 1 over 1 over 25. Now, look at this at first glance, you're going like, well, there's no way you're going to make 1/25 base 5. So this comes in. No, it's still possible. You can change 1/25 because 1/25 is 1 over 5 squared. And if you remember your negative exponent rule, 1 over 5 squared is 5 to the negative 2. So this 1 over 25 becomes 5 to the negative 2. And then tack on the x plus 2 on that side. And then 5 to the x plus 1 up here does not change. So then we just drop off the bases. So x plus 1 equals to negative 2 times x plus 2. And now you're in the same boat that you were in example 4. You'll need to distribute the negative 2, move around the terms around a little bit, isolate the x, and you're done. But you got to remember what you're doing here. All you're doing is just kind of determine where on the Cartesian plane they're crossing. So these two graphs are going to be crossing at negative 3. These two graphs are going to be crossing at 2 places, 8 and negative 1. These two graphs are going to cross at 7/8. And whatever we get here and here is where they're going to cross. So, but as far as sections are concerned, this is probably one of the easier ones that you're going to do. So that concludes this part.